Hello, and welcome to another episode of Breaking News. My name is Ricardo Valls. I'm the president and founder of Valls Consultant. And in today's episode, I will be explaining a technique that I use very frequently. It's called the RCC, or Range Correlation Coefficient, which is a method that I developed many years ago. And I will make this video to explain step by step how to do it, and also how to make a graphical representation of the obtained RCC. Also, the video is being recorded in English, but if you want to read the closed caption in another language like Spanish, Russian, French, whatever, you just need to select the closed caption option in YouTube, and in settings, select the language that you would like to use. I am showing a video of how to do this right here. Okay, so let's jump on the example. We start with a correlation matrix, and I am assuming that you already open your data and process it using CodaPack, converted to ALR, CLR, or ILR, any of the algorithms of CodaPack. And so we can use the normal correlations that we obtain from Excel or any other statistical package. Here in this table, I'm only showing you the significant correlations. And in order to do that, we use the formula. It's called the student criteria, which is basically this formula here. We have the correlation divided by root square of 1 minus correlation square multiplied by square root of the amount of data minus 2. But in geological practice, if you have more than 30 samples at a probability of 95%, if your student criteria is bigger than 3, we can consider the correlation as significant. In this table here to the left, I have ordered all our correlations starting from the most negative to the most positive. As you know, correlations vary from -1 to 1. This gray area here are the correlations that are not significant. So we start with this table, and we will get the first pair of elements, in this case, gold and nickel, which has a negative correlation, which means that one element will be in the numerator and the other element will be in the denominator. You can put any element in the numerator or the denominator, but we know that we are looking for gold, so it's just easier for us to keep the gold on the numerator. The next element is cobalt with gold. Cobalt has a negative correlation with gold, so it will appear in the denominator. Okay, but because we have gold a second time mentioned, we will put a little asterisk there, meaning that we have already mentioned gold 2 times. The next correlation will be copper with nickel. The copper will be in the denominator, and the nickel, because it has been shown a second time, will have the same asterisk. And we will continue doing this until we get to finish. We have already finished all the negative possible combinations. Okay, and in this case, we obtain an RCC that is composed by 3 times copper, 2 times gold, 1 time silver, divided by 3 times nickel, plus coal, plus lead, plus zinc. And I will suggest you to stop the video for a little while and on your own try to figure out where this bottom part of the table, where these elements are going to be, and which kind of numbers are going to be in the formula. I will make one more, for example, gold, copper. They are both here. That means that I will add 1 point for the copper and 1 point for the gold. So let's stop the video, think a little minute, and see the final result. And this is the final result of the RCC. Okay, now I'm going to explain you how we can make a graphical representation of this coefficient, which is an excellent tool to interpret the mineralization and sometimes even the geology. In order to do this, we're going to need to have a circle, a ruler, and some colored pencils. And of course, a little sheet of paper. And we will start by organizing our table again from the most negative to the most positive. But now we need to do a little calculation. And this little calculation is this column here, which I call L. And L is not length. L is in honor of my wife, Ludmila, when I created this method many, many years ago. So what this formula here that you see is converting the values of correlation into a distance. And why 4? Is because after doing this many, many, many times, I know that if we start at the center of a page with the first 2 elements separated 4 centimeters, we will get the whole graphic into one page. So we here have all our length now, okay, converted. And of course, the stronger correlation will be the closest one. The weakest correlation will be the ones that are separate. So we start with gold copper. We put a little circle for gold and copper, and we put them at 4 centimeters distance, and we join them with a straight line in red. That means that this correlation is significant and is positive. The next element will be the gold with cadmium. We know that cadmium is 4.22 centimeters away from the gold, but that doesn't fix a point in space. We need to have 2 points in order to fix it. And if we look here, the cadmium has also a 4.24 distance from the copper. So it's 4.24 from the copper and 4.22 from the gold. We take our circle and we make 2 circles. One of 4.22, one of 4.24, and in that place where both circles intersect, that will be the position for the cadmium. You, of course, could have put the cadmium down here, but I always tend to construct the graphic towards the upper part of the sheet of paper. And again, all these correlations are significant and are positive. That is why they are joined by a red continuous line. Now, the next 2, copper, mercury, and cobalt, nickel, they don't have any pair that we can use to locate them in space. So we'll jump again to the negative part. So we have nickel that have a negative correlation with gold and copper at distance of 596 and 587. Again, we take our circle and we trace a circle of 596 from the gold and 587 from the copper, and the place where those 2 arcs intersect, that will be the position of the nickel. In this case, there will be a blue line, discontinuous line, indicating that these are significant but negative correlation. The next element that we can join is cobalt, and cobalt will be a combination of the negative with the positive, because we know there is a positive correlation between nickel and cobalt of 4.56, and it's a negative correlation between cobalt and gold. Again, we make our circles of 5.8 from the gold, 4.56 from the nickel, and we find the location of the cobalt. Okay, again, if you don't have the circle, actually I made this in PowerPoint. You can just make different circles and adjust the diameter, and you get the same effect. So the next one will be the location of the lead. I will suggest that you stop the video a little bit and trying to figure out where the lead is gonna fall. So here is where the lead is gonna fall. The lead has a negative correlation with the cobalt and the nickel. So it would be a blue discontinuous line. The final element was silver, and silver has a positive correlation with copper, but no other correlations with anybody else. So we just put it there hanging in the air. And this is very, very important. That is why I'm telling you that this method is very good for interpreting the geology and the mineralogy. It is clear from this example that the main mineralization is a gold, copper, cadmium. Cadmium is usually pyrite. And the silver is not part of this main mineralization. It's just an element that appears related only to the copper. Also, lead is not in this case an element that is related to the mineralization. It is related to the lithology. This cobalt nickel correlation probably is indicating an ultramafic rock, and in many cases we have lead as part of these ultramafic rocks. So this is how you do your RCC and the graphical representation of the RCC. If you want to rotate this, instead of starting with the main two elements, you can start with any other ones. For example, you could start this with cobalt and nickel, and then the graphic will, when you control the graphic, it will be like you are rotating it and looking from another side. I hope this presentation was useful for you, and I look forward for our next meeting on Break News from Valls Consultant. Have a great day.
I think these videos are brilliant, and I'm sure you will like them too. Please like, comment, and subscribe, and don't forget to click the notification bell.